So my name is Melissa Good. I also go by Missy, and I'm the statewide mariculture specialist for Alaska Sea Grant. I'm also the Kodiak Seafood and Marine Science Center, and I'm located in Kodiak. Go ahead, pass it off to James.
Yeah, hi all. I'm James Crimp. I am our shellfish mariculture specialist. Oops, sorry, at Alaska Sea Grant. I also spend a lot of time out in Dillingham in the summertime. My family's a set net operation up there, and my folks used to live in town. So yeah, I can't really see who's in the room. You're tiny on my screen, but good to see some maybe familiar faces, and looking forward to chatting with you all. And I'm based down in Juneau.
Yeah, so James and I are going to tag team this presentation. He's driving, so I'm going to be telling him next slide. So if you go to the next slide, James. For those of you that don't know, you probably do because you have TAV, but Alaska Sea Grant is actually a partnership between the University of Alaska Fairbanks and NOAA. There are 36 Sea Grant programs across the United States, located on our Atlantic and Pacific shores and the Great Lakes as well. The Alaska Sea Grant program is a statewide program. We have agents and staff really across the state, and we have a mariculture team. This is our mariculture team led by our director, Ginny Eckert. There's myself and James. We also have Aaron Jones, who's our mariculture technician, who's here in Kodiak. We have Jessica Whitney, research staff in Juneau, and then we have a mariculture research fellow, Rachel French. Next. And we were asked, Alaska Sea Grant was asked by the Alaska Mariculture Task Force, which sunset in 2021, to stand up the Alaska Mariculture Research and Training Center. This is not a brick and mortar center, it's more of a virtual center. And really our goal is to bring together the research, education, training opportunities that are occurring across the state for the state. So we have a great website where we post upcoming events and opportunities. We also have really amazing social media pages. So follow us on Facebook, Instagram, and LinkedIn. Jessica's our lead on our social media, and she does a really nice job. So if you want to know kind of what's going on across the state, get updates, those are the places to go. Next slide. In Alaska and in our program, we very specifically say the term mariculture. Mariculture is a form of aquaculture. Where very specifically, mariculture is the enhancement, restoration of farming of marine organisms in a marine environment. So that marine environment can be shore-based or it could be actually out in the ocean. And in Alaska, it is just shellfish and seaweeds, as fin fish farming is illegal in the state of Alaska. Next slide. Currently, there's varied species that are being cultivated and researched on across the state, but really Pacific oysters makes up the bulk of organisms that are farmed in the state. And James is really going to go into some more details on oysters. There's a little bit of blue mussel production, but that kind of wanes. And there's also some geoduck farming that's occurring in Southeast Alaska. As far as the seaweeds go, oh, backward, thanks. Seaweeds go, we're primarily farming the kelp species. Kelps are the brown seaweeds, the big, large, leafy bladed seaweeds. And it's sugar kelp, ribbon kelp, or bull kelp are really the primary species being targeted and cultivated. Next. There is a lot of interest in other species as well. Abalone, sea cucumber, sea urchins. There are several other species of kelp that are being grown right now. Three-rib, dragon. There's interest in red seaweeds. Dulse is a primary food source for cultivated abalone, especially in tank-based systems. And we have research in Juneau going on with that. There's a lot of interest in scallops, growing the geoduck industry. There's certainly a vast amount of wild harvest of geoducks. There's interest in razor clams. We've seen decline in a lot of our razor clam species, especially in the Cook Inlet. So restoration is a really big thing here, and potential of other clam species. Next. This is a map that comes from the Alaska Department of Fish and Game, and this shows the aquatic farming operations across Alaska. And these are farm sites as well as nurseries and hatcheries. And you can see those green and black dots. Those are all where a permitted site is. There are 99 permits across Alaska. You can see where those are, ranging from southeast to Kodiak. There has been other permits issued. Sandpoint, the Shumagon Islands, ADAC, but those have, the folks have either decided not to do that or are working on some, going through the permitting process. 70 of these permits are considered active. It doesn't mean they're necessarily selling product every year, but either they're interested in cultivating and they still have some gear in the water, or, it could be that like for geoducks, ducks, for example, it takes 7 years for them to actually grow up to a marketable size. It's 11,374 acres that are permitted for aquatic farm production. Not all of this space is being used. Most farms have a larger permitted footprint than they're actually using. Farm sizes range between 1 and 182 acres. Those 1 acre plots usually being oysters, so for shellfish production, with the larger plots being for kelp production. And then we could see a percentage breakout going from southeast to westward areas. Westward, in this case, in this map, being Kodiak. Next, and I'm going to switch it over to James.
Yeah, thanks, Missy. So yeah, we were gonna kind of set up this talk to maybe focus on basically how to grow three of the species, or three kind of groups of species: oysters, kelps, and then also maybe get into clams a little bit, which are a bit more experimental, but might have some interest in Bristol Bay. But yeah, so we're just gonna kind of go over these species in a little bit more detail. So this first slide shows you basically the size of oyster production in Alaska. And you can see that there's been, the industry really, it started along, like, I think 60s or 70s or something. There was the first permitted farms, but it's really seen most of its growth since 1990. And there's been some waxes and wanes. You can see this graph only goes up to 2019, when there was a big dip in the number of oysters sold due to COVID, because a lot of oysters get sold in restaurants. So that was a bit of a struggle. But since then, the industry's rebounded. And then this graph on the right shows, in orange, it's the number of oysters that are actually sold from farm to farm. And that's because there are some farms that make their kind of a big part of their living selling smaller, or raising oysters to a small size and then selling them at that small size to other farms where they get grown out to market size. Or sorry, I guess it's blocking my screen a little bit. Yeah, to other farmers, that orange, and then to the public, or sold at market size is that blue. And so you can see there's sort of steady growth through 2022, and then in 2023 you can see there's this big spike in kind of this to other farm sales. So that means that there's a lot more juvenile oysters out in farms right now. So the number of oysters reaching market will very soon expand quite a bit in Alaska. So yeah, oysters, it's been a relatively small industry for a long while, making up somewhere in the low like $2 to $5 million in sales. So very small compared to like commercial salmon fishing or something like that. But there's a lot of focus on growing industry right now. There's a lot of potential for growth. So that's why we're us at Alaska Sea Grant and others are working on this industry, is just that potential for growth. And so how are oysters grown? Oops. Okay, hope you can still. So oysters get so basically oysters start off their life in the hatchery stage, and so this is when you have on the left, you have broodstock oysters that are can be males or females, and they under the right salinity and temperature conditions, they release their gametes, sperm and eggs, into the water column, and then they become larvae for I believe a week or two, and then so there's free swimming larvae in the water column, moving around until they find somewhere good to settle, and they're generally given some like sand or some other crushed oyster shell to settle onto in the hatchery, and then they become basically tiny little baby oysters. And in the early stages in the hatchery, basically they spend their first 2 to 4 months indoors generally, and they're fed a diet of cultivated microalgae. That's what you can see in this middle slide here is this several different types of microalgae being grown in the lab to feed to these oysters and give them just the ideal conditions to thrive in their early years when they're the most vulnerable. Then they get transferred into this. On the right, you can see this sort of nursery stage where all those little dots in these bottles are tiny little oysters. There's probably, hundreds of thousands of oysters in each of these bottles, and they get fed this microalgae, and then give the get given the right conditions to grow as quickly as possible. After this nursery period, they'll generally move on to a in the water nursery. So this is kind of what's called a flupsy or a floating upweller system. So this system, you can see on this left, this is a barge down in Prince of Wales Island in Southeast Alaska, and there's this paddle wheel that is powered, and it brings up water from kind of the depths underneath this barge up to the surface, and the water down deep is a little bit more nutrient rich. So it brings up water, and then it pushes them through these silos, which are these kind of welded aluminum boxes here that have these tiny little mesh openings that allow water to move through and then move through these juvenile oysters. So you can see here, these are oysters that are maybe half a centimeter big or something like that. So this is another stage that causes them to grow up as quickly as possible. And then once they become a centimeter or more, they'll get transferred out to a bunch of different grow out configurations. And this is kind of the stage where most oyster farmers in Alaska come in. Some oyster farmers own these things that are called flupsies, but a lot of them will buy seed from another farmer that manages a flupsy, and then they'll grow it from a centimeter or larger to 2.5, 3.5 inches, at which point they can be sold to the market. And I'm a set netter and kind of just marine, love tinkering with different kind of marine configurations. And I think this is what a lot of oyster farmers really enjoy. Is there's a lot of different ways to grow oysters from this stage to market size. So I was just going to show a couple here. This is one that's really popular in Alaska, basically where you have these floating racks that are at the surface, or these floating rafts, and then there's lines that come down from these rafts where these racks of oysters live. So each of these rafts might have, 40 or so of these racks of oysters. So you can pull them up, bring them over to your farm operation, and then sort them out. So that's one way that you can grow them. Another way that's become a lot more popular in recent years is floating cages. This is a system called an oyster grow cage, where basically you have two floats that are at the surface, and you have this cage that the floats suspend just below the ocean surface. And in each of these kind of rectangular things, there's just a smaller bag of oysters. And so the beauty of these cages is it keeps the oysters really close to the surface, where the water is generally the warmest. And then you can also flip them over for maybe 24 or 48 hours at a time. And the oysters will survive when they're out of the water, but the rest of the crud that grows on them will die away. So it really helps with a lot of the biofouling. So here's kind of what operation of a flipping one of these cages looks like. You can see all these cages in the background, or all these floats in the background, and each of them looks like this. So they're a little unwieldy to flip, but they're pretty rugged and withstand weather very well. Oops, sorry. And then another operation, another way that you can raise oysters is through a flip farming setup, which is sort of like the last one, but with these smaller containers. And you have basically, yeah, a single float on each of these cages, and then you put oysters inside these little oyster jails here, and and then you can have them. For the most part, the cages will be down in the water, and then the floats will be out of the water, and the farm will sort of look like this. And then you can flip them over once you want to dry. You want to have the oysters out of the water and have them dry out for a day or two to get rid of the oyster fouling. So this is kind of one of the systems that is really efficient and allows you to grow oysters with relatively little manual labor. And then there's other ways that you can grow them too. This one I wanted to throw in because, as we know, there's a lot of tide in Bristol Bay and a lot of mud flats. So one way that is pretty popular down in Washington State to grow oysters is that you have these intertidal arrays, where basically the oysters are submerged for most of the time, but when the tide comes or when the tide goes out, they are exposed to the air, and then all of the fouling on their cages dries out, and the oysters get a little bit cleaned. And then a nice thing about all of these kind of surface culture intertidal systems is that the oysters, as the tide's coming in and out, the waves are thrashing around the oysters a little bit, and it ends up sort of chipping away the edge of their shell, and that causes them to it actually stimulates growth and stimulates the oysters to form this deeper cup, which is more desirable to the market. And so if you don't have that, or if you do and you just want to stimulate more of this growth, what a lot of the time being an oyster farmer is you are uh, taking the oyster, you're cleaning off that gear that you have in the water, and then you also need to take the oysters out of that gear and then sort them out by size, because you want the bigger grower oysters to stay with the bigger oysters, and then maybe the slower growing oysters to stay with the same size class. Otherwise, the sort of speedy growers will sort of outcompete the runts of the litter and cause them to grow even slower. So what you're doing a lot of times is you're taking out the oysters, you're cleaning them, and then you're also sorting them by size. So this is a machine called an oyster tumbler, and you have smaller holes in this tumbler up towards the top, and larger holes towards the bottom, and then the bigger oysters fall all the way through the tumbler. This is an example of kind of what it looks like. So you've taken your oysters out of the cages, and then you're sending them down through this tumbler. You can see that some of the oysters are falling through those holes, and then some are moving down towards the bottom of the tumbler. And then on the right here, you can see that the when you're sending them through the tumbler, when the oysters are being jostled around, the leading edge of their shell gets sort of chipped away, and you can see this white is where that's happened, and then that encourages more growth and a deeper cup in the oysters. And so, yeah, once oysters are somewhere between like 2 and 4 inches, it really depends on your market. Generally, the nice thing about oysters is that they're sold live, they're sold unprocessed, other than being kind of cleaned. And so you can just sell them in these bags like this. You have to keep them cold. Generally, you want to get them to a market fairly quickly because they will perish after a couple weeks or so. Um, but yeah, you're keeping them cold on their way to the market. And then, if you've ever been to an oyster bar, all they do for most Alaskan oysters, at least, is that they shuck them and then put them on some ice and serve them with some lemon or a little sauce, and they're good to go. So compared to salmon or seaweed, as you'll see in a little bit, they're very easy on the processing side of things. And so there's basically, as you're thinking about becoming an oyster farmer, you want to first know that you have a good site for your oysters. And so some of the factors that affect how quickly oysters grow will be temperature. Oysters can grow between 3 and 28 degrees Celsius, but optimum conditions are between 10 and 22 degrees Celsius. Basically, the higher the temperature the oysters are in this range, the faster they're going to grow. So in Alaska, we have pretty slow growing oysters in general, compared to the same species are grown down in California, and they might take maybe a year and a half or 2 years to reach market size, whereas a lot of oyster farmers in Alaska, it'll take them 3 to 4 years for their oysters to reach market size. So the faster the oysters grow, the more quickly, or basically the less expense you are going to have to, or the less time we're going to have to expend on growing them and cleaning them and doing all the sorting and things like that. So we're at a little bit of a disadvantage in that way, but also we grow really tasty oysters up here in Alaska, and we're known for our very high quality seafood. So that helps make up for this growth time. Salinity is another thing. Oysters can grow between 10 and 35 parts per thousand. Optimal conditions are 20 to 35. So that's something to think about, if you grow in an area like close to Dillingham where some of the water can be quite fresh coming out of the rivers. You do want to find a place where the water is at least fairly salty. Another thing is that oysters eat phytoplankton. So basically, phytoplankton are, all the tiny swimming photosynthesizing organisms in the ocean, and they grow where there's light. So you need to, they're pretty prevalent, anywhere where the water is clear and there's a good amount of nutrients. But in like the waters right off of Dillingham, where there's a lot of mud in the water and there's pretty much no visibility, you might not be able to find a lot of phytoplankton in that water. So that's something to think about. And then you want at least some water movement, something that wouldn't really be an issue in the bay, but more water movement will cause the oysters to kind of like jostle and chip and get more food. So having some water movement is key. And then some more considerations if you're thinking about starting oysters. Yeah, like I said, how many years will it take your oysters to reach market size is a big thing. So if you're growing in really cold waters, say you were farming up in Nome or something like that, it's going to take a long, long time for your oysters to reach market in very cold locations. So finding as warm of a spot as possible is great. So often people will farm up in little bays and inlets where the sun will maybe warm up the water in the summertime. Um, how far away is your market is another consideration, because you have to keep your oysters cold and help and alive as they go to that market. So uh, a lot of farmers in Alaska try to sell as close as they can, but then once they grow to a larger volume and they sort of saturate their market, they might have to ship them further away or even down to the lower 48. Can you brand your oysters in a way that consumers will appreciate? This is kind of an interesting thing where oysters, they're sort of similar to like wines or craft beer or something like that, where a lot of people will buy them because of their brand. So, thinking of ways, a lot of people in Alaska brand their oysters as glacier fed oysters or something like that. So finding ways to market your oysters that makes them unique is a helpful thing for your bottom line. Can you hire good workers? Always a good consideration. And then what existing infrastructure can you use? So a really cool thing about oysters, and basically all farming in Alaska is we got lots of boats up here. Down in like the Homer area, the Kenai Peninsula area, there's a lot of set netting down there too, and really cool oyster skiffs that are converted set net boats. Set net boats make great work skiffs. So that's a nice thing for areas like Dillingham or other fishing hubs to help when they make that crossover. And yeah, now I will pass it over to Missy to talk a little bit about seaweeds.
Yeah, so seaweed production, which, like I mentioned, is primarily kelp. There's a little bit of red seaweeds and green seaweeds that are sold that have naturally set onto oyster gear. Otherwise, it is cultivation and it is the kelps. We saw our first farm in Alaska go in 2016, with the first harvest being in 2017. And you can see in this graph, which is the years on the bottom and the pounds and thousands of pounds on our y-axis, is that we had exponential growth. So we had a huge amount of growth going all the way up to about 900,000 pounds. And then we saw a pretty precipitous drop off in 2023, and 2024 is going to look similar to that. We don't have the final, or the state doesn't have the final numbers yet. But that drop off is primarily due to lack of markets, and lack of markets is being access for Alaskan farms to the markets. The global seaweed industry is worth quite a bit, with a significant amount of seaweed going into it, but we're trying to figure out how Alaska can fit into that. Next slide. So if you're interested in potentially farming kelp, there are some rules in Alaska that you need to abide by in starting all of this. And so in the state of Alaska, for every kelp farm that's out there, they're required to get parental stock, so reproductive tissue from adult plants that are in the wild every year. And you have to get that parental stock from within 50 kilometers of your farm site and from a minimum of 50 individuals. And so you'll go out and say we're doing bull kelp. Here's our bull kelp example. And if you look in the top left corner, that picture, you see the bull kelp bulb and the beautiful fronds. And then the little subset picture is of the sori, or the reproductive tissues. And bull kelp is nice because they're really obvious. There are these really dark brown patches on those blades. So a farmer's going to go out and they're going to find these patches. They're going to collect them. They're going to do a little bit of prep work on them, and they're going to send them to a state certified hatchery, which there are several across the state. And so once they do that at the hatchery phase, they're going to get them to release their spores. I'm showing that in that graph. I'm not going to go into too many details. They're going to reproduce, and then they're going to settle onto what we call seed string. So these two pictures that are in the middle with those brownish tubes, the one on the top is a hatchery. This one is one down in Southeast Alaska. And each of those tubes are just plastic PVC tubes, but wrapped around them is a small twine. And so the hatchery, they wrap this small twine around these tubes. They put them in aquariums. And so you could see the PVC piping that actually is moving the water around. And it's really hard to see, I apologize for that, but in the picture, they're in clear, like acrylic aquariums. And so they put the spores from the kelp into the aquariums, and they like to settle on that seed string. So it's like a nice spot for them. So they'll settle and reproduce and then form little baby kelp. And that's what we see in the tote in that bottom picture. Those seed spools are really brown. That is all just little tiny kelp growing on there. And this process all occurs in the fall and can range between, it's usually September through November. And the hatchery timing is 6 to 8 weeks. So 6 to 8 weeks from those spores going into those aquariums to getting that nice thick brown growth. And then once we get that nice thick brown growth, it goes out to the farm sites where they put the seed spools on it. And if you could see the gentleman in the orange, his left hand is right by a seed spool, and he's actually getting the twine that's on the seed spools onto a larger diameter grow out line. And we'll see some more pictures of that. So next slide. And there are several different farming systems that have become popular. The first one, the easiest one, is a single line array. So this is really just, it's 2 anchors. You can see on the left, on the right on that schematic. The very top schematic is the overview. So if you were, a bird in the sky looking down on it. And then that bottom one with the blue on the top and the brown on the bottom is if you were standing in the ocean and looking at your farm, you can kind of see those little anchors drawn. The line towards the surface, towards that blue line, is your grow out line. So they're taking that little tiny seed string, they're wrapping it around that grow out line. And this is happening in the fall, early winter timeframe. And that line is just out there. So it's 1 anchor on each end with 1 line in between it. That's probably pretty easy to visualize. So that's outplanted in the fall. And then by the time late spring comes, usually we're starting about April. And so that April through June is the harvest period. And over those 6 to 9 months, you get this beautiful growth. So this is all kelp that has grown over that time frame. Next slide. A spreader bar system is another popular means. It's a pretty simple system. Rather than having one line between your anchors, you have multiple lines between those anchors. You could see a system that's laid out on our pilot plant floor here. That is a course that we are teaching. So you see the metal bars are the spreader bars. You could see on that middle bar 3 coils of line. And so those coils of line are going to string between all 3 of those spreader bars, and that keeps your lines nice and taut. And we have a picture on the right-hand side of a spreader bar system in the water. Those buoys are just being used to hold up those lines. Kelp likes to be close-ish to the surface, usually about 2 meters or 6 feet from the surface. And we can see lots of kelp. That brown fuzziness is all kelp growing on those lines, that spreader bar system. Next. Next, we have a catenary system. So this is a tension-based system. What's nice about this system is it's the most efficient system that we have out there, where you have many lines. You could see in the schematic on the top, all the surface lines that are the grow out lines in the middle. These kind of curved lines are part of the catenary, so that's that tension-based system. And then the black lines are going out towards our anchors. So this system, sorry about that, requires a lot more anchors. So it's a much more expensive system because anchors are clearly expensive. But it's a much larger system that's more robust, so you can grow a significant amount of kelp on it. And you can see the little squiggly lines, that's kelp growing off of our schematic. And then if you look at the bottom, we see a skiff that's over our catenary system. The curved line, again, is that tension line that's holding our farm together. It's surrounded by a frame. Then each of these middle lines are the grow out lines. In this picture, they have the system set, but you can't see any growth on them. So you see the white of the grow lines. And then as time goes on, the kelp will start growing. And by spring, you should have a nice dense harvest nice dense crop to harvest. Next slide. And so kelp harvesting. Harvesting looks different everywhere you go. Each farm has kind of their own methods. Here in Kodiak, they have the harvest buddy, they call it. That's that little barge here on the top. This was designed by a federally funded project for harvest efficiency. And so what they're doing is they're pulling up 1 grow line at a time. This is off of one of those catenary-based systems. And they've tried like hedge clippers and all kinds of things, but found a Vicky works the best. So they're using a Vicky just to slice off the kelp from the lines, and they're going right into these brailer bags. So in the picture on the top left, you can see the brailer bags that are full floating at the surface. Very conveniently, they just float. But the one that they're filling is right in the middle, so that dense grow line with all the kelp is going up. We can see the gentleman with the black and orange jacket. Below him is a brailer bag that is kind of in between those 2 pontoons. And as they cut the kelp, it's just falling into the brailer bag. Once it's full, they pull it around and they just tie it onto the buddy and it floats there. Other methods being used are a seiner can go out, and so the seiner will pull up that grow line, and again, they'll just use a Vicky, they'll cut it off into these brailer bags and float them, and then if depending on transport, so you need to transport your kelp to a processor. Sometimes these bags will get towed if it's if it's a short distance, but if they have a distance to travel, they'll have totes on board, just regular IBC, fish totes, and they'll put the brailer bags into those fish totes. The bottom right is a skiff, and these guys is set net skiff, like James was mentioning. Full utility vehicles, but they put a frame on it. So again, they're pulling up that grow out line, 1 grow out line at a time, and utilizing common resources in Alaska, another brailer bag. And so they'll fill their brailer bag up, and the square that the brailer bag is holding, or the square that the brailer bag is holding, they actually have it mechanized so it will flip up and flip that broiler bag out of the skiff. So that way it'll flow alongside them and they can just tow it along. Kelp has a very short time frame from the time you harvest to the time it gets processed. So you have about a 24 to 48 hour window from the time that you harvest your kelp off your grown lines to you stabilize it. Next slide. So the processing side is incredibly important. So it's important that farms are close enough to a processing facility to get that kelp into a stable state. And there are various ways to do this. You can sell your kelp fresh. This is really common on the East Coast where farmers have direct access to restaurants and universities and other places that will use the kelp for food products. But in Alaska, it's not really doable. You know, we don't have millions of people right down the road to give fresh kelp to. So it has to be stabilized. And that can be done in several different ways. It can be blanched. And the blanching process is pretty cool. You could see in the picture in the middle, that's a drying rack that we have. And the brown kelp is ribbon kelp that's just fresh, put on the drying rack, you know, we'll dry it. But you can see kind of that bright green kelp. There's some at the bottom, come right in the middle there. That is the exact same species of kelp, but it has been blanched. And so the blanching process actually leaches out a lot of the enzymes that cause it to degrade and then leaves in chlorophyll. And so there's a lot of different pigments in kelp that help them utilize the sun. But chlorophyll will stay through that quick blanching process. But that's what it's there. It's green. You don't have to blanch if you're going to dry, but drying is a method. Salting is a method. So just adding salt on it will last for a very long time. You're essentially changing the pH. And then fermentation. Fermentation is becoming a really popular method for stabilizing kelp. And what we'll see is kelp will get usually ground or rough chopped and then put in IBC containers and then adding like lactobacillus or lactic acid bacteria into that container. It changes the pH and makes it stable. And that is a good way of preserving it at ambient temperatures, your outside temperatures. As we all know, cold storage is incredibly expensive because you could freeze your kelp. Issues with freezing kelp are that if you blanch it and freeze it, it does great and has a shelf life of a couple of years. But if you freeze it prior to blanching it, once you thaw it, it just kind of turns to mush. So if you want food grade kelp, nobody likes, most people don't like mushy food like that. That's kind of slimy. So you do have to blanch it. So processing equipment becomes an issue. Kelp is currently being purchased for about 50 cents per pound. So at 50 cents per pound, you do need to harvest quite a bit to actually make a living out of it. Seed string's about 50 cents a foot, and farmers are growing thousands of feet, tens of thousands of feet. And so it's rather costly and your margins are pretty low. Next slide. But here in Alaska, we do have kelp that's being produced. Most of it is being processed for food grade kelp. We have a couple of companies in town that are making salsas and are in town in the state. Salsas, different sprinkles, additives like the furikake, which is really popular, hot sauces. There are several breweries that are putting it into beer as a flavor additive. But seaweed is used in many, many things. In 2023, the seaweed industry was valued at $17 billion. And this is mostly cultivated seaweed with some wild harvest, but mostly cultivated. And projections are showing that the cultivation side is going to grow, but not the wild harvest side, because kelp forests are being protected and rightly so. It is projected that the industry will reach to about $35 billion in 2032. So there is a potential, while we're not seeing it right now, but there's potential for this to be a huge market that us and the Western Hemisphere can participate in. Right now, over 90% of the seaweed going into these many products comes from Asia. But I have some examples here of, where it can go, and you can see it's huge. Medical materials, fertilizers, cosmetics, drugs, food products, and really many more. if anyone's a home brewer out there, you've probably used Irish moss in your home brewing. It's not from Ireland, nor is it a moss. So the name is a little confusing, but it is a seaweed. It's a red seaweed. And really, it's a clarifying agent. You put it in there, it takes all the solids out of your beer and gives you a nice, clear beer. But it could do many other things. It's in your ice cream. It's in your toothpaste. It's in your shampoo. It's in most products that you're finding in the store. And it's the components of the seaweed that are being broken apart at a biorefinery that are then being put into these many, many other products. So there's a potential there. But when we look at places that are producing most of the seaweed, they're getting 1 to 2 cents up, not even a pound. And so it's bringing it up to scale. Next slide. Oh, so what do kelp like to grow in? They don't like freezing temperatures. They can't freeze. If the kelp freezes, it usually will kill it. It doesn't like freezing temperatures, so it doesn't like ice. So you have to avoid ice. Kelp is being grown in icy places. Greenland has actually developed a system with Norway where they sink their farms below the ice for the wintertime. And it grows under the ice. Spring comes, the ice thaws, they start getting their lights, but now they have lots of nutrients in the water and they get great growth. So there are systems in place to avoid the ice, but it's something to think about if you were wanting to farm kelp, is trying to avoid these ice areas or having systems in place to sink your gear and your farm. It also doesn't like it when it gets too warm. 59 degrees has kind of been shown to be where its cutoff point is. It starts to degrade after that. And then kelp like salty water. They like very oceanic water. They can tolerate some amounts of fresh water, but it has to be a short period of time. They do not like a lot of freshwater inundation. Kelp have a very high nutrient demands. Nitrogen is usually a limiting factor. We see places like Prince William Sound where there's a lot of glacial runoff. There's less nitrogen in the water, and kelp doesn't grow as well in places such as that. So oceanic water, it needs lots of current because of those high nutrient demands, and morphometrics is a concern there too. But kelp is a photosynthetic organism. It's like a land plant. It absolutely has to have sunlight to grow. Usually 6-7 meters is about a maximum depth you can get depending on visibility. We do see most kelp farm sites that are non-buoyant kelps, like this ribbon kelps and sugar kelps, growing at like 2 meters or 6 feet depth. But you're going to go deeper as you get buoyant species like bull kelp. And that's another thing too with sedimentation. If you get a lot of sedimentation in your water, the kelp aren't going to like it either. They really need some clear water where they're getting good direct sunlight. Mountains are also an issue in some places. If you are putting your farm in a valley that has limited sunlight, especially in the springtime where you're wanting to get all of your growth, you could get limited growth from the lack of sunlight. And because there's such high nutrient demands, kelp like the high energy areas. They like areas with a lot of water motion, just bringing those nutrients in. And then some species are really dependent on having water movement to form structures that the market wants. Barnacle Foods is a good example. There are farms that are working on growing bull kelp, but the bull kelp, rather than being these long, beautiful stipes that are a certain diameter, they're getting like short, stubby ones, or something that is less desirable for kelp pickles and things that they're making. Next slide. And if you're thinking about starting up a seaweed farm and industry in Bristol Bay, there are some considerations to take into place. Is there going to be enough seaweed to make it worthwhile? So actually to have a processor there that is willing to process it. Here in Kodiak, the primary processor of the seaweed, they use a local fish processing facility. It's a direct marketing fish processing facility owned by the local tribe. And what they do is they shut down in the spring. They take out all their fish processing equipment. They do a deep clean. They move the kelp processing equipment in, just process kelp, because the kelp is being processed for human consumption. fish protein contamination is a concern for allergen reasons. So all the fish processing equipment gets taken out. They process kelp for the season. And then once that's done in May, June, they need to be ready for the salmon season. So then they take all the kelp processing equipment out, put the fish processing equipment back in, and they're ready for the salmon season, which is not really a good thing because you need to treat kelp more like a land crop where you don't know when it's going to be ready. Each year is different. And if you miss the window of when your crop is ripe, then you get biofouling. Critters love to live on kelp, live in kelp. And once it's got fouling on it, it's not really good for human consumption, but could be good for other things like fertilizer, soil amendments, or just, biorefining for the components. So things to think about. Quality, of course, because kelp has such a short time frame from being harvested to stabilization, you need to be able to harvest it and get it stabilized relatively quickly, and you need to be able to do large amounts of it. Are there local resources that can be utilized? The Shunak tribe wild source plant is a great example here in Kodiak, where while the timing may not fit perfectly, it is a processing facility, a certified processing facility, so you can move in, make food grade products, and be able to sell it. Reliable transport, we are talking tens of thousands of pounds, and can you move that around? Certainly we figured it out with other industries, but can you do it with kelp? There has been some work of putting harvested kelp into seine holds, but there's contamination issues there with fish proteins again. Also, kelp sticks to everything. So if you have a circulating water system, you could have issues just because of the stickiness of it. Can you access a market? That is the biggest struggle in Alaska right now, is accessing markets. Can you get good workers? The timing, does the timing work right? Is there enough of a processing labor workforce in April to be able to, process large amounts of kelp? And the bottom line is, are you going to make money? Because this is a money-making industry, right? We were cultivating kelp usually for to sell, to make money. Next slide. All right, I'll switch it over to James.
Awesome. Yeah, and I'll speed through this just so we have maybe a little bit of time for questions. But just wanted to throw out, so clam farming is like Missy said, geoducks are being started to be cultivated in Alaska, but it's a pretty nascent industry. Clams are grown in other areas, and often what it will look like with clams is, most clams prefer living in the sediment. And so what you're doing as a farmer is you are growing out clams in a hatchery / nursery, kind of like I showed for oysters, and then you're planting them in the sediment. So this is a geoduck farm, I think, in Washington, where you have maybe 2 to 3 geoducks in each of these little PVC tubes, and then you have a little bit of predator net over top of them to keep predators, crab or whatever else from digging in and getting to your clams. Or you can do it this kind of system. This is, I think, soft shell clams in Maine. You can have larger plots where you plant a bunch of clams in these rectangles, and then you cover these rectangles with, a big sheet of predator netting. I think that in Maine is to keep green crabs out. Or you can also grow them. This is another experimental operation in Maine where you've got bottom planted clams in cages that you can lift to the surface beneath an oyster farm. So there's many ways to do this. I think wanted to throw this out because I know clam harvesting, I think over in Togiak, I've heard is a thing over there. And if you were to grow them, it sounds like you might be competing with walruses over there. So figuring out a way to keep your clam, if you were to grow them, to keep them in your bellies, not other organisms' bellies would be key. So yeah, that's clams. Same thing, phytoplankton, temperature, and then just predators may be a larger issue. Maybe I'll skip over that slide. Yeah, maybe you want to go quickly through resources, Missy?
Yeah, just real quickly, I mentioned the Alaska Mariculture Research and Training Center. If you search AMRTC, you're going to find it. And our website link is here at the bottom. But I would recommend subscribing to there if you're interested in learning more. We have a regular newsletter that comes out that shows funding opportunities, educational opportunities, training opportunities, upcoming events. And so please subscribe there. And again, our social media is awesome. It's really well. And there's lots of like fun pictures that get posted from ongoing research projects. And this website actually lists a pretty comprehensive list of what the current research projects are going on in the state. Next slide. There's a fairly lengthy permitting process. It's about a year to get permitted for an aquatic farm. I won't go into the details of that, but we did put together a website, the Alaska Aquaculture Permitting Portal, and this website steps you through what that process is, and there's a PDF guide you can download. We're currently updating it, but the updates are fairly minimal. Next slide. And there's also the Alaska Mariculture map. And so this is a siting tool. I don't know if you heard this as we were talking, but siting your farm is one of the most important things because you need to have a site that your organism wants to live in and will thrive in. And that is essential. Your farm will not flourish whether you have a market or not if your organisms aren't happy growing where you're putting them. We were going to step through this, but I think we might be running out of time. So maybe we skip that, James.
Yeah, definitely.
Yeah. All right, and I'll pass it over to you.
Yeah, just throwing out some examples of upcoming trainings that we have at Alaska Sea Grant. We have an oyster hatchery nursery training in April, and then a seaweed handling and processing workshop in May. If anybody's interested, feel free to get a hold of us. And yeah, I think with that, we'll try and leave a little room for questions. I'd be curious to hear, if anybody in the audience kind of has some sites or species that might seem to you might be suitable in Bristol Bay. I'd be happy to chat through anything. So thanks all.
Thank you. Any questions?
Yeah, for the kelp over in Togiak, we get a lot of herring eggs on kelp.
Yeah, that's a really good point. So, obviously herring love kelp, and when you are siting your aquatic farm, the state is going to review where herring spawning sites are as well, and they will not allow you to put a farm site in where herring are known to spawn. Herring can go wherever they want. We can't control them. And so, for example, there was a farm in Southeast Alaska. They put a rather large kelp farm in, and it was a site that no one had ever seen herring spawning at. Well, the herring came in and they spawned on the farm, the entire farm. And the state of Alaska will not let you touch the kelp that has herring eggs on it until every egg has hatched. And so you cannot harvest the kelp for the herring eggs. You have to just leave it be. And then once the herring eggs have all hatched, certainly the eggs shells are still attached to the kelp, and the kelp is no longer food grade. It could potentially be used for fertilizers or something else. But that's a consideration also. There's, a lot of interest in actually putting kelp farms in Prince William Sound for herring restoration to see if they could help herring come back to that area. The state is really struggling on how they permit that.
So that was a limitation for for kelp. Is it the same for shellfish?
I think it's the same as in, the state will look for any kind of adverse impacts to surrounding wildlife in where you're going to site a farm. But, I don't think you would get herring laying eggs on oysters like you would with kelp. It's just kind of not, at least I've never heard of that. And maybe in Togiak, there are so many herring, it could be an issue. But but yeah, generally, I think with shellfish, you might have other things you want to consider. Marine mammals, like I said, walrus would be one that you probably need to pay attention to a little bit if you're gonna, if you're gonna like use mud flats or use an area where the walrus might already be harvesting a lot of shellfish that are on the ocean bottom. Or eelgrass is another one. I don't know what the situation is with that in Togiak, but eelgrass is organism that often is protected and often grows in areas where you might also want to grow oysters. So just figuring out those kind of dynamics and just working with your local regulators. ADF&G has got some really good folks that are on their mariculture team. So chatting with them earlier rather than later in the process is the way to go.
Yeah, that's definitely highly recommended. And when it comes to aquatic farming, it's kind of the bottom on the list. And so if there's any other uses in an area or opposition from people from the area, it's not going to go through. And so they're looking at marine mammal haul out areas. They're looking at migratory pathways. And so the state is looking at that and going in earlier than later, talking to the regulatory folks, talking to the tribal organizations, really anyone that's in the area that has the say or jurisdiction.
What are some risks with the kelp farming besides the herring
Like as far as the consumption of the kelp or for other organisms?
for other organisms?
Marine mammal entanglements are always concerned because you do have lines in the water. As with fishing, like with pots, we recommend that you don't have any loose lines, that you have taut lines. We thankfully have not seen any marine mammal entanglements. But that is a very high concern. We actually have a very large research project going on right now, the Mariculture project that was funded by the Exxon Valdez Oil Spill Trustee Council that's looking at the impacts of aquatic farms in the spill area. So Prince William Sound, Hatchmack Bay, and Kodiak. And it's looking at everything from the physiochemical effects, the phytoplankton, fish, marine mammals, seabirds, how are these farms impacting how other organisms live around these areas? We are finding that juvenile fish love to hang out in these farms. And so they could be a nursery repository, as well, where, they're coming in, they're schooling, they're protected because they have growth, from other organisms. And things like to live on kelp. So there's kind of more of a boom than a bust.
So I see your hand is raised.
Yeah, can you hear me okay?
Yep.
Okay, sounds good. So I'm just wondering what the potential is in the Chignik Bay subregion on the Pacific side of the Alaska Peninsula. There's kelp, there's oysters, there's bidarkies, and some of that's been documented. But do you know offhand whether there's been any research done in that area? Because there's potential interest on the part of some of the communities there.
Yeah, I've heard interest from the Chignet area for a while, and I've given several presentations to them to see what we could do to help. There has been work on paralytic shellfish toxins, which is a huge concern with shellfish. And so if you do have high toxins in the area, it's something to consider. Otherwise, it's all about site selection and looking for sites that are good for the organisms that folks want to grow, and then transportation of your product. So getting it out to market is going to be something that you need to consider and work on it as well. And when it comes to shellfish, what's unique about shellfish and the permitting is that you're actually going to have to do water quality testing for about a year. It ends up being a little bit more than a year before the state will permit you to grow shellfish for food consumption in the area. So you have to be able to send those water tests out to the state lab, which is in Anchorage. And so making sure you can get a water test out, and they want it, I don't remember the time frame, but it's like 48 hours or 72 hours. We'd have to look in what it exactly is now with the state lab. So you have to make sure to get a flight out, right, for your sample that you're taking. So that can be limiting. And then shellfish as well, before you can sell it. Sorry, James, I should be jumping on this.
Oh, no, you're great.
But I've been here longer than James.
Yeah, I'm learning some things too, Missy.
It's so for your shellfish, you're gonna have to get it tested by the state lab for paralytic shellfish toxins before you can sell your shellfish to be consumed. So again, you have to take a sample and then you have to send it out and you have to get your approval from the state, and then you could sell your shellfish. And so that's a consideration as well. It's these shipping logistics are going to be a huge thing.
Yeah, no, understood. And I'm assuming that perhaps you've been in communication with people like George Anderson, with CIC and others. And, you know, transportation does become an issue, you know, because Chignect Bay itself is a deep water port. You know, they get cruise ships, incredible cruise ships that come in with several hundred people, offloading for just, you know, just for the day. But if the weather's bad, it could be it could be several days. And I know it's tough to sometimes meet the time constraint, you know, to get your water samples tested. But and then just and I think James is aware of the website, and I assume you might also be, the Chignect Watershed website and some of the symposiums. I can send that to James, and he could send you the website link, because there's again, we're just wrapping up a watershed plan, and then DEC Aqua just recently issued a grant, you know, for Chignect Bay to do a stormwater management plan. But anyways.
Yeah, yeah. I think I found the website, but I'll wait for James to send it to me as well. Make sure I have the right one. You know, and there's a lot of potential for kelp there as we're developing these markets, because you can do ambient stabilization. So you could just be putting it into these, you know, IBC containers, which hold thousands of pounds, with like lactic acid or something, and you don't need very much of it. And then it's stable for quite a while. So then you could fill up shipping containers full of these IBC containers to go out to wherever that market is going to be. We're trying to figure it out to make it, you know, worthwhile, economically worthwhile. But that has a lot of potential. We've been working with the villages around the Kodiak archipelago, doing kind of small scale trials on how can you get your kelp, you know, do a quick clean and grind into these containers, so where it's not as labor intensive, but then you could just store them outside, right? You don't have to have cold storage or anything until you have enough to be sent off for further processing. So there's future potential.
Well, thank you.
All right, well, thank you guys.